Question number 2 from section 3.1, quadratic functions. This is a lot like the first one, but this time I'll go through just a little bit faster. So for the first one, I want to give the domain and range. The first domain is the x values. You can plug any number in for x. You're not going to have any restrictions on the domain. If this graph were to continue, it would go forever and ever to the right and to the left. It would keep getting wider and wider. So the domain is everything from negative infinity to infinity, because the graph will continue to get wider and wider going out in both directions in along the x-axis. The range is the y values. How low does this graph go and how high does this graph go? This graph is going to keep going forever on the y-axis, keep going down forever, and it's going to go up, and the highest the y value is right here. That's the highest y value. It's going to go from negative infinity all the way up to -2. So the way we write our range is from negative infinity to, +2. And we're going to put a bracket there because it does actually touch. So again, when you look at the domain, it's how far to the left and how far to the right the graph is going to go. This graph is going to continue to get wider and wider. That's why I've listed here that it goes from negative infinity to infinity on the x-axis. Now for the y-axis, in the y direction, this graph goes forever down the page, and it's going to stop the highest that it gets on the y-axis as at +2. So that's a way that we can look at domain and range. Let's enter our answers and check our work. So the domain, again, all real numbers, negative infinity to positive infinity, and the range is negative infinity to +2. Oh, I should have put a bracket there. Bracket, because it actually does touch. Well done. For part B, we want to give the coordinates of the vertex. You can do this by looking at the graph, and you can see that the vertex, the highest point of this parabola, has coordinates -5 and up 2. You can also find those values by looking at the h and the k in the equation. So again, the vertex, by looking at the graph, is -5, 2, and also by choosing in parentheses an x +5, so it's the opposite of the +5, and the +2 on the outside. So that's going to be our vertex at -5, 2, and let's check our answer. Good job. For part C, we want to give the equation of the axis of symmetry. Again, that axis of symmetry is that vertical line that goes right through the vertex, that cuts the parabola in half from left to right. It's a vertical line. It only goes through the x-axis. It only goes through the x-axis, so the equation is going to be x equals wherever that vertical line crosses, and it's going to be -5. X equals -5 is the axis of symmetry. To find the y-intercept for part D, we want to determine where this graph is going to eventually, way down here, is going to cross through the y-axis. The best way to do that is to plug in 0 into the function for x and simplify the results. Okay, I do what's in the parentheses first. 0 plus 5, I get 5. So -2 times 5 squared plus 2, square first the 5. So you get -2 times 25 plus 2, then multiply by -2 to get -50 plus 2, and then -48 is your y-intercept. So you would really have to make a huge graph all the way down to negative 48 to see that that parabola is going to cross through the y-axis at negative 48. To find the x-intercept, you want to locate on the graph where the function crosses through the x-axis, and on the x-axis looks like it crosses through at negative 6, negative 6, 0 is an x-intercept, and over here it looks like it crosses through negative 4, 0. The way you can do this without having to look at a graph is by setting the whole function f of x equal to 0 and solving the equation. And that looks like plus 2 equals 0. I'm going to subtract 2 from both sides of the equation, and we get negative 2 times the quantity x plus 5 squared equals negative 2. And then I'm going to divide both sides by negative 2. And those are going to simplify these. So we'll get x plus 5 quantity squared equals negative 2 divided by 2 is 1. And then you're going to take the square root of both sides. When you take the square root of something squared, you have to set up two equations. So you get x plus 5 equals plus or minus 1. So you're going to set up one equation where x plus 5 equals a positive 1 and x plus 5 equals a negative 1. Subtract 5 from both sides of the first equation to get x equals negative 4. Subtract 5 from the both sides of the second equation to get x equals negative 6. So our two x-intercepts are negative 4 and negative 6. Okay, let's look at number 3. We're going to choose the graph that represents the function f of x is equal to x minus 1 quantity squared minus 1. Now, if you're familiar with the basic graph of y equals x squared, that basic graph is a parabola that opens up. The minus 2 inside the parentheses indicates that this basic graph has been shifted to the right 2 units. That minus 1 on the outside indicates that your basic graph has been shifted down 1 unit. So our graph is going to be the graph of this basic parabola, but we're going to move that vertex to the right 2 and down 1. So it's going to be a parabola that looks like this. Now another way you can do that is making a table, but this isn't always the most effective way, most efficient way, because you want to make sure you choose enough points so you get the parabola shape. So I would choose points, because I know this is a shift 2 and down 1, I would probably choose a few points for x, including 1, 2, and 3. When you plug 1 into the original equation for x, 1 minus 2 is negative 1. Negative 1 squared is 1, and 1 minus 1 is 0. If you plug in 2, 2 minus 2 is 0. 0 squared is 0. 0 minus 1 is negative 1. And plug in 3, you get 3 minus 2 is 1. 1 squared minus 1 is 0. So that corresponds to these points right here on the new graph. Out of the choices we have on my math lab, this one looks most like, I'm going to have to really zoom in to choice D. It does look like it's the basic parabola that's been shifted to the right 2 and down 1. So I am going to choose D. Let's look at number 4. I'm going to pause the video here and start a new one because this is going to be rather lengthy.